All right, today we're talking about a really big deal in AI called Dino v3. It's a story about how researchers fix this totally bizarre paradox that was holding back how AI learns to see the world. And trust me, it's a fascinating one.
So, here's the question at the heart of all this, and it's a real head-scratcher. How can an AI get smarter and dumber at the exact same time? I mean, think about it. You're trying to make it better, you give it more data, a bigger brain, more training time, and somehow, while it improves in one area, it starts getting worse in another. How on earth does that happen? Well, that's what we're going to figure out.
Okay, so before we can really crack that paradox, we've got to rewind a little bit. We need to understand the honestly kind of magical way these AIs learn to begin with. And it all starts with this idea of learning without labels. This whole approach is called self-supervised learning, or SSL for short, and it's a game changer. See, instead of the old way, where you'd have to pay tons of people to label millions of images like that's a cat, that's a car, that's a tree, SSL just lets the AI loose. You just dump a massive, totally unlabeled pile of images from the internet in front of it, and it figures it out on its own. It literally teaches itself to see patterns, objects, and textures just by observing, kind of like how we learn as kids. And let me tell you, this technique worked ridiculously well. The model that came before our new hero, a model called DINOv2, basically became the gold standard. It used this exact method to build this incredible foundational understanding of the visual world. You could then take that foundation and apply it to all sorts of different tasks, and the best part? No need for all that tedious, expensive human labeling. It was a huge win. So, if you're a researcher at this point, the next step seems super obvious, right? If it works, just do more of it. Scale it up, bigger models, more data. What could possibly go wrong? Well, this is where our story takes a sharp left turn into something called the big model paradox. Right, so that's exactly what they did. They took the winning formula from Dino v2 and just supersized it. We're talking a much bigger model, billions more parameters, way more data, trained for way longer. Everybody was expecting this thing to be a total game changer, a huge leap forward. But yeah, that's not what happened. Not even close. This is where they hit the wall. This is the paradox. The model actually did get better at the big picture stuff. Ask it, is that a dog or a cat? And its accuracy would just keep going up and up. Awesome! But for anything that needed fine detail, like, hey, can you draw an outline around every single thing in this picture? Its performance just tanked. It got worse and worse. It was learning what was in the picture, but it was completely losing its mind about where things were. And you can literally see what was going wrong inside the model's brain right here. On the left, this is the model early on in training. Look how sharp its understanding of that parrot is. The features are clean, they're localized, it knows what's what. Now look at the right. This is after a million training steps. It's a total mess. The features are all noisy, they're bleeding into each other. The model's just confused. Its amazing eye for detail has just vanished. So the big question is, how do you fix an AI that is basically learning itself into a corner? How do you stop it from getting dumber the more it learns? Well, the brilliant folks over at Meta AI came up with a really elegant solution, and they call it the Graham anchoring fix. Okay, the best way to think about this is with an analogy. Imagine a brilliant artist, right? They're amazing at the big picture, the overall composition of a painting. But as they work longer and longer, they start getting, kind of sloppy with the small details. Their brushwork gets messy. So what do? You give them a reference photo from a time when their detail work was at its absolute sharpest. You remind them what excellence looks like.
So that's basically what Graham anchoring does. It's a new training stage where you force the current, kind of sloppy model to remember the structure of the image. You make it maintain the same relationships between all the little patches of the image as an earlier, much sharper version of itself. It's like having a teacher model, which is actually just a snapshot of its younger self, constantly looking over its shoulder, making sure it doesn't lose that fine detail. And the process itself is actually pretty straightforward. It's just 3 steps. First, you let the big model train like normal, letting it get awesome at those big picture, high-level skills. Step 2, you slam on the brakes at just the right moment, right before those detailed features start to get messy. And finally, step 3, you bring in the Graham teacher, that snapshot from its peak, to guide the rest of the training, anchoring it and making sure all that incredible detail gets preserved. So, did it work? Oh, yeah, it worked. The results are, and I'm not exaggerating, absolutely spectacular. This is the part where you don't have to take my word for it, because seeing is believing.
I mean, just look at this. The difference is staggering. It is night and day. On the left, that's the old way. It's that noisy, confused mess we saw before. But on the right, that's Dino V3. It's just perfect. The understanding is incredibly clean and precise. You can make out the bicycle, the fence, every little detail is perfectly separated. It's just wow. And check this out. Look at this incredibly cluttered, complex scene of a fruit stand. Dino V3 is so precise now it can pick out all the individual bunches of grapes. See all those highlighted areas? That's the model saying, I think these are all grapes. The researchers had a little fun with this in the paper. They actually ask, do you agree with Dino V3? What do you think? I mean, that's an incredible level of precision. Okay, the visuals are stunning, but what about the hard numbers? Well, they tell the same story. Look at this chart for semantic segmentation. That's a super hard task that requires insane detail. Dino V3 in blue isn't just a little better. It absolutely crushes its predecessor, Dino V2, and other major models. This is the proof right here. The paradox is officially solved. And it wasn't just on that one task. It was a clean sweep. On all the most challenging, detail-heavy benchmarks, Dino V3 just set new records. For segmentation, it jumps from 48.8 to a whopping 54.9. For depth estimation, where a lower number is better, it drops the error rate significantly. For 3D matching, it pulls ahead again. There's no debate, this is the new king of the hill for detailed computer vision. All right, so this is all really cool, but you might be asking, why does this one weird paradox matter so much? Well, the thing is, this fix doesn't just give us a slightly better model. It gives us a completely new and much stronger foundation for pretty much the entire field of computer vision. I mean, just think about the possibilities. An AI that gets both the big picture and the tiny details, that's basically the holy grail. Suddenly you can build robots that can actually navigate a messy room. You can have AI that analyzes video with stunning accuracy or understands geospatial data from satellites. It even opens up doors for next-generation generative models. This changes everything. And just to show off how flexible this thing is, the researchers took Dino V3, which was trained on regular internet pictures, and applied it to a totally different world, satellite imagery. And get this, it achieved state-of-the-art results in estimating the height of forest canopies. That's a super critical tool for things like monitoring climate change. It just goes to show how powerful and adaptable this new foundation truly is. So by finally cracking this scaling paradox, Dino V3 has basically given AI a new pair of glasses. It can see our world with a clarity and a level of detail that just wasn't possible before. It's a massive leap forward. And it leaves us with a really exciting question to think about. If AI can now learn to see the world this clearly, all on its own, what's it going to see next?